Welcome to the Mr. Beacon podcast. This week we are going to be rejoining one of our favorite guests, Ollie Smeenk from SODAQ. SODAQ are a really interesting company. They do custom engineering, but they also turn some of that custom engineering into products. They've got into a lot of sustainable IoT products. We're going to be talking to them about a smart label that they've produced, which is being used by a major drug company to transport things around the world. And it uses cellular networks and NB-IoT. So we're going to be asking, what is NB-IoT and how do you make something that is the thickness of a few sheets of paper work on a cellular network, and what the applications are. And I think we'll get some interesting insights. I know we're going to get some interesting insights from Ollie. He's a great world traveler, a globetrotter. He is calling us from Singapore. Enjoy. Ollie, welcome back to the Mr. Beacon podcast. It's a pleasure to have you on again, second time.
Thanks for having me again. It's always a pleasure talking to you, Steve.
Well, I've always been drawn to you and your company, SODAQ, because of the environmental sustainability aspect to your mission. But you're also really geeky into the depths of creating radio devices, IoT devices. And I saw that you had a paper-thin tag, which could be used for tracking things, which is obviously, that's the space that I work in for my day job. But your tag is different. It's a wide area tag. It uses NB-IoT. So I want to talk to you about that. Maybe you can explain to us what NB-IoT is, we just want to check in with how SODAQ is doing, any interesting projects, and what your perspective is on the industries that you focus on. You've been into the pharmaceutical space, agrochemical, I guess, and others. So you talk to a lot of different companies, really get into the details, understand IoT. I thought it would be good to catch up. Sound okay?
Perfect.
So maybe for those people that haven't seen the first episode where I interviewed you, can you give us a quick summary of who SODAQ are? Give us an intro to your company.
So SODAQ is a company based out of the Netherlands. And for 10 years now, we just had our 10-year anniversary. We've been developing hardware products for the Internet of Things. So our strength really lies in the hardware development, finding the latest technologies when it comes to how to print certain technologies or make thinner or lower power devices that last longer in the field. And we do this for different industries. So we develop tracking devices, we develop sensing devices, and we've done over 250 different custom hardware engineering projects. In the last 5 years, we added a few products to that. So we converted some of those developments into our own products that we also offer to the market with a service. And those are all in the domain of tracking. So track and trace of things ranging from shipping containers to air freight containers, airport equipment, seed bags, all the way down to cardboard boxes. And so in that space, you need different form factors, different battery life, different features. And so SODAQ stands for Solar Powered Data Acquisition. So there's solar is a core element in there. And we have always built solutions with solar panels. And so one of our, let's say, flagship products is a solar powered tracking device that lasts for more than 5 years with just continuous updates of its location and temperature and motion conditions. But about 4 years ago, we were approached by one of the largest agriculture and pharmaceutical companies in the world, Bayer, to develop a label that would autonomously send its location, temperature, and motion information, but that wouldn't be so bulky as to not be sticking out or protruding from the surface of whatever it's tracking. So we set out to develop a label, which of course you're very familiar with what labeling needs to be like. But for them, it needed to connect directly to the cellular network. So we needed quite a large battery. And we were fortunate enough that at around the same time, printed batteries that could give enough power to send a signal through NB-IoT or LTE-M would be possible. So NB-IoT and LTE-M are basically the lowest power consuming technologies of the 4G, 5G kind of cellular GSM spectrum. And so with these beautiful type of thin batteries,
wow, that is thin.
You can these are from two different suppliers. You can basically send a cellular 4G, 5G message, which is not our invention, but it's a fantastic invention, because it previously wasn't possible to do that with anything that was thin, basically.
And what are these printed batteries made of? Because obviously there are all sorts of issues with sending batteries through the post.
Yeah.
Presumably the materials you're using avoid those.
Yeah, so these batteries are based on zinc, and one of the types is zinc in combination with carbon. The other one is zinc with manganese oxide. These are all safer than lithium, for example, and so it's not possible to puncture them. It's not possible, or you can cut through them basically without making them explode.
Yes,
they're not toxic. They're not flammable. Exactly.
Yes.
And the manufacturers of these batteries even go as far as to say you could technically eat them like a vitamin, but I wouldn't go that far myself.
No. So what are the routes that these packages, so what are these things going on? What is it that needs tracking like that?
So one of my favorite examples is something we actually been building in a bit more recent times. It's this one. So this is a smaller version of the label. It also has a similar printed battery inside. It's a bit thicker because it's stacked.
Okay.
And so these go inside medicine boxes. So you have this medicine box, and basically it goes in with the medicine, and then it's in the factory, placed in the box of the medicine, so that the entire journey from production all the way to consumption, the temperature is monitored, and actually the opening of the package is monitored as well, so that, for example, the moment of consumption is seen to be either before or after the expiry date, for example. And with this tracking, they can prevent parallel trade, counterfeiting, and pharmaceuticals are the most interesting field for this type of tracking, because the value and the sensitivity of the product are significantly higher than any other industry, and therefore the price can be a bit higher of this service of tracking them.
Are these tags going into every box? So it goes into the secondary packaging for the medicine. Is it going into every single one? or is it sort of going into one in a case of this? Are you sampling, or are you basically part of the serialization of every single thing?
If the if the medicine is of high enough value, then the intention is to track every single one of them. But there's plenty of medicines that are not high enough value, and there they would be applied to a carton or a larger box, and then the individual packages would potentially use another technology to be tracked, in that way having some sort of serialization.
Okay. And then, how do you know whether the box has been opened? How does the sensor figure that out?
In this specific device, we have placed a light sensor as well as an LED, so a light, and we can see the color change if the box is opened of the light that's emitted.
That's really cool. So it's tamper detection in a way, or opening detection without having to break a fuse or anything. So much easier to manage. You just stick one of these things in the carton, and you're good to go.
Exactly.
Very good. Okay, so and where is that? How far have you got in this deployment? You've obviously got a product developed, or it looks like you've got a product developed. Is it deployed yet?
So the current state is that we are producing the first few hundred pieces now, and going into trials with some of the top 5 largest pharmaceutical companies in the world, that are actually using it in their real life shipments.
Williot's my employer, for my day job. We got some experience with tagging individual vaccine vials, but the challenge that we had was, it's a complex supply chain, and our Bluetooth devices talk to Bluetooth infrastructure, and so when you kind of get out into clinics and that sort of thing, hard to know whether that infrastructure is going to be there. You don't have that problem. Basically, presumably anywhere there's a cellular service, you can communicate. Do you have like worldwide coverage?
Not global. So not all countries have an active network for this specific low power technology. But we are selecting specific routes. So, for example, our customer wants to send things to Turkey or India from Germany or so. Then we make sure that the connectivity we have is enabled on those networks. For example, right now, large parts of Africa are not don't have such networks available, and so we have to wait until it's deployed in those countries before we can actually track shipments to those places.
So it seems like NB-IoT is not globally deployed, but there's enough countries where this is viable.
Exactly, and we do foresee that it will grow the network, especially as these types of applications become more widely adopted.
And can you tell us a bit more about NB-IoT? How is that different from regular cellular communications? How does it differentiate?
So the frequency that is used, so the specific way in which the radio modulates to send signals over the antenna at a certain frequency is different than with the type of LTE or 4G, 5G that you would use with your cellular phone. Also, the signals go one way. So there's traffic basically going from the device to the cell tower, and then it can send something back, but it cannot do it at the same time. Whereas your phone typically has 2 antennas that can send and receive at the same time.
Okay.
Which all decreases the cost and the complexity of the modules, as well as the complexity of communication and the energy consumption.
And then, what is the cost of the communications? Like, it's not like where I have to buy a SIM for my phone, and that has a bunch of setup costs and that sort of thing. How do you typically pay for that LTE-M or NB-IoT connection, and how in turn do you pass that on to the drug company or whoever, the shipper? Is it just a pass through, or how is it billed?
The way in which it's charged is, since it's a device that is used once, the cost is a lifetime cost. So you basically pay a certain fee one time on the moment that it's activated, and after a certain duration, it will be automatically deactivated again. So there's no setup cost, there's no billing based differences based on where it goes or how much data is consumed, because it's so limited in its scope. And then we actually charge the customer for in a similar way for just using the device once, and it's included. The connectivity is included in there, and then we charge for additional services on top of the simply getting the data from the device, for insights, gaining more control over the supply chain, and things like support to resolve certain issues.
And what can you tell us about how much all of this costs? Maybe not be as specific as you can, or be as vague as you must be.
So you have to think in the range of, for now, $20 to $30 dollars, depending on whether you get the smaller or the larger label.
So that's how much the label costs, and then what about the service costs? What's the ballpark for that?
So the labels include a basic service, so connectivity, access to data, etc., within that $20 mark. And then all the other services on top, they become relatively cheaper the more devices that are purchased, because these are, in a sense, costs that do not marginally increase in the same way, or do not scale in cost the larger the number of devices that are purchased.
Very good. Well, that's a super interesting area. Is there anything that I didn't ask you about that I should have asked you about, that typically people do ask about those labels? Oh, I know. There was one thing I did want to ask. What do you do about airplanes? Because airplanes, they don't like it when you start operating radios on airplanes. And that's always one of the things that the Bluetooth community is always very proud of, is you can use Bluetooth on a plane, but as we all know, they don't like you using your cellular radios on a plane. That's why they're always reminding us when we're taking off. But I remember going to a meeting of the Bluetooth Special Interest Group where we had the guy who actually rode on the planes and did the first tests with Bluetooth, and convinced the FAA that the jets were not going to fly out of the sky when the Bluetooth signals were used. But how do you overcome that aversion to non-Bluetooth radios on planes?
So we're not allowed to transmit on the plane, that's for sure. And so the device needs to go into an airplane mode. And we can either, in a very simple way, use the motion sensor to detect whether it's moving. So whenever it's moving, it doesn't transmit. And whenever it's in a plane, it is always slightly moving, or moving a lot. So that's one technique that costs the least, that only requires to use the motion sensor, which is in there anyway. But it's also possible to expand that with other inputs. So whether it be a barometer sensor that detects changes in pressure, or using the radio module to detect changes in signal strengths and things like that, you can apply some intelligence to make use of the device when it's not flying. But we prefer to stick to just the motion sensor approach.
Who do you have to convince that this is meets the regulations? Is there some kind of FAA certification, or is it down to the airline or the transportation company you're using? How have you had to approach that?
So the first thing that you need to do is, or we needed to do, was get a DO 160G certification. And with that, we have to convince every single airline or airline group individually of being allowed to transport these products on their planes. So it's quite a lengthy process, which of course, in the case of Bluetooth, you don't have to go through any of that.
And how's that going? How far have you got through with that negotiation with all of the airlines?
So ourselves, we have a good relationship with DHL as well as Lufthansa. So these are airlines that we do multiple different types of projects with. But for the pharmaceutical industry, we actually work very closely with a company called Controlant, and they have been shipping loggers for many years. So they have all the connections to the airlines, and they are doing the certification process with the airlines for the smaller pharmaceutical label. And we hope to be able to leverage that in the future for our other products as well.
It's very cool. Good. Anything else we should cover on the label front?
Yeah, it's not related to cellular, but there's a trend, I would say, or a future technology. There's two things. One is I think we were both at an event recently about printed electronics.
Yes.
And
TechFlick, right?
Exactly. Yeah, I really foresee the industry moving towards additive manufacturing. So I also have here like these examples that I was given of temperature sensors, different types of modules that can be printed. In the future, we really want to print all of the solutions that we have. Right now, we're still using what you call subtractive technology, which is kind of in a way, a waste of materials, harder to recycle, and also actually costlier at volume. So that's an area that we're working with manufacturers on to make conversions for.
And could you just explain that term, additive? What does that mean?
Additive means that you have a base layer that you use, let's say plastic, for the flexible electronics, and then you print it can be like a printing press, like the way that a book is printed, for example. Using a stencil, you can print the actual copper layer or another type of metal that's conductive that connects the different chips basically with the intelligence together in order for it to become a functioning device. Whereas subtractive is where you have a base layer of copper and you actually use lasers or another type of technology to cut away parts of the copper in order to create kind of the pathways that are conductive and then the pathways that are not conductive in order to make the electronics function.
It's that etching process where you're cutting away. Obviously, you have a huge amount of waste, which not good for the environment and not good for cost either. It's actually something that we've been looking at for our own products to reduce the cost. And we're looking at essentially printing antennas on cardboard boxes, sticking chips on in order to reduce layers, reduce costs, make it more sustainable, lower the carbon footprint. And so how is the business going with regards to the solar-powered devices, that core use case? I think a lot of them were going on shipping containers. And I think this is one of the big trends that's going to start growing explosively, is not just tracking the container, but tracking what's in the container. That's the thing that I'm interested in. But if you're going to track what's in the container, then you need to have the container online. And so having some solar-powered connectivity is really handy. How would you say the state of the nation or the state of the world is with regards to that use case?
We are using these solar-powered devices, indeed, to track three types of containers. We have containers with seeds inside. We have containers that go on airplanes, so air freight containers, and then shipping containers. And the units are both able to communicate their own position, temperature, motion information, as well as listen for signals from Bluetooth transmitters and forward their information as well. So you can have temperature information from different and motion and location information from different packages or goods within the larger shipping or air freight or seed container, that way having a more density of information, but also more value, because sometimes you need to know what's going on inside the container in order to ensure that the goods are properly transported in a safe and at the right temperature approach.
I think that's really cool. It's a very exciting development, seeing that start to scale.
I would like to close off with just one thought. So we've been working on these Bluetooth tags that are active, that I think the main thought around them is that there is just such a global network of mobile phones that are continuously everywhere, that I see the future being that one day all mobile phones will be gateways for all types of beacons. Because why install another SIM card in the each individual device and waste costs, waste energy, and so I'm sure you're on a similar vision there, and would love to see where that goes.
No, I agree with your forecast of the trend. We are starting to use more and more mobile devices in stores and warehouses to almost crowdsource the signals that we get from tags. And there's a lot of benefits to having a mobile reader rather than fixed infrastructure. It tends to be lower cost. You also tend to avoid kind of the black spots because you're moving around and constantly getting different angles for the radio waves to permeate and get to the cloud. So I agree. So why is it that interesting shape, the thing that you showed me?
Well, we're actually using these for a very specific use case that will soon become public. So I'm not allowed to give away the business case yet, which is a good thing in a way. It's quite large because it needs to be visible. But soon, maybe on the next conversation, I'll be able to share more on the actual use case of those. But it's not tracking.
Okay. So for those people that are listening, which I think a lot of people do, then this is is it hexagonal or it's a multi-sided? It's how many sides is that? It's
It says
two,
X
four,
X
six.
six.
Is it? Yeah,
Yeah, six
six-sided.
sides.
Uh, some kind of printed circuit board thing. Very intriguing, very colourful. As are you. Again, I always enjoy our conversations, Ollie. Thanks for coming on the show, and we'll move on to the next part now.
Thanks for having me.
So, Ollie, you've been on the show before. Last time I asked you about music, we agreed we would give music a rest, and you are one of the most globe-trotting people I know. You're supposedly based in Holland, but you're not in Holland at the moment. Where are you?
I'm in Singapore.
Okay. How do you like it? My wife was actually just in Singapore. She's now hiking the Himalayas. Last time I saw her, she was in Kathmandu. So,
Wow.
but she showed some amazing pictures of Singapore. How do you like it?
Singapore is beautiful. So it's really green. It's all very modern and well kept. I actually went to the Singapore City Gallery yesterday, where they lay out all the plans for the future and where it came from. And it's just amazing to see how the city has evolved and how much investment they put in making sure that things run smoothly, because it's one of the most densely populated places on the world. And it's just all operates so efficiently. And it's safe, amazing food. So it's really a nice place.
Yeah, I think the original development was driven by the East India Company, so not a great history from that perspective. But the result is this amazing kind of safety net for people that want to peek into Asia. And I love the Singapore sling and raffles, and then you walk down the road and there's like very small, authentic Malaysian restaurants and all sorts of things. Amazing. So what we agreed I would ask you was, I don't know if you remember, but what your top three places that you visited, rather than top three songs, top three places. So
Yeah.
what are they?
I think number one is Rio de Janeiro.
Oh, never been. Would love to go.
I love Rio. It's like developed in some parts, but at the same time, quite chaotic in other parts. So it has an amazing balance in that sense, and just a very vibrant culture, and people are very engaged with each other. Anyone could pass as Brazilian. There's no like you cannot look Brazilian or not Brazilian. So everyone's welcome. It's culturally my favorite place.
So very kind of melting pot, accepting. That's good.
Yeah.
What's number two?
Number two is Mexico City.
Oh,
Yeah. I was very surprised by Mexico City. So I think just after I saw you earlier this year, I in San Diego, I went to Mexico City because it was kind of the closest I had ever been to Mexico, and yeah, it was beautiful. It was surprising how safe and how calm certain areas of the city are.
yeah.
Where the image that's portrayed sometimes externally about it is that it's quite a hectic place, overly packed, but it just has so many of these nice neighborhoods and beautiful art scene. A lot of creatives from the US actually moved down to Mexico City to live there.
Cheaper to live, I assume. It's the cost of living is a bit lower.
Way lower, yeah. So it really it's a bit of a slower life in a way as well. And if you want to get access to the hustle and bustle of the city, you can as well. So it's, again, I think there's something to do with my upbringing, I mean, I grew up in Dar es Salaam in Tanzania, which is also just like a wild place.
Yeah.
And sometimes can be quite chaotic and unorganized, which I think adds really an edge to a place. But then, funnily enough, I would say my third would be Singapore now, which is totally the opposite. There's no chaos here.
No throwing your chewing gum on the pavement. Definitely don't want to be caught smuggling in any illicit substances.
No.
I once wrote a screenplay for a movie which has never been made.
Really?
Which is set has a scene in Singapore where one of these high-tech executives is set up by his boss and is caught with marijuana in his suitcase when he's going through customs, and it's basically a way of finishing him off. So there, I've given away a key plot point for outrageous options, which has not been made yet. But if anyone wants to make it, then I'm open to offers.
Would love to read it.
It'll be up there with Beacon Technologies, The Hitchhiker's Guide to the Beacon System, which has been turned into a book, but probably will never be turned into a movie. Well, 3 amazing cities. I have been to 2 of them. My memories of Mexico City were the food was incredible. It was pretty cosmopolitan. And I remember seeing a bunch of guys spinning around a pole. They were spinning around a pole. They were elevated in the air. And there was, it's weird how you get these images, but it was some kind of celebration. But great cities, great to hear some of the fruits of the globe-trotting that you do, Ollie. Thanks for coming on the show.
Thanks for having me again.
Thanks for watching this episode of the Mr. Beacon Ambient IoT podcast here on YouTube. You can listen to this episode on iTunes, Spotify, or wherever you get your podcasts. If you enjoyed it, please like and share this video. And be sure to subscribe for more videos. For more information about Wiliot, Ambient IoT, and IoT Pixels, head over to wiliot.com.